Hello. In this video, I'm going to walk you through an example of calculating the periodicity of a signal. Let's start with a quick definition. A function, x of t, is said to be periodic with t naught if x of t plus t naught is equal to x of t for all t. But what does that mean exactly? Let's take a look at a simple example of a basic sinusoid. So here we have two graphs, a cosine wave on top and a sine wave below. This is something you've probably already seen and utilized in previous math courses. Both sine and cosine are periodic with 2 pi. We can see this visually on the graphs, the curve of each repeating after intervals of 2 pi, and this would continue on forever. But we can also observe this mathematically. Say, for example, we have cosine of pi over 4, and we know this to be radical 2 over 2. If we add 2 pi, then we have cosine of 9 pi over 4. And this still comes out to radical 2 over 2. You can plug that into a calculator or just go off your knowledge of the unit circle. And this also goes for adding 4 pi, 6 pi, or 8 pi. If you add any integer multiple of 2 pi to pi over 4 in this expression, the answer will still be radical 2 over 2. So we see how the basic concept works, but how do we determine the periodicity of a more complicated signal, specifically a sum of sinusoids? For this example, I'm pulling numbers from the Sum Sinusoids Periodicity MATLAB Demo, so you'll be able to visualize this later. In this example, we have two cosine waves being summed, each with different angular frequencies. Additionally, they have different amplitudes and phases, but we're not worried about that here. We're just going to start by plugging in t plus t naught to the x naught equation and distributing that out. So we have cosine of 20 pi t plus t naught plus 0.6 cosine of 21 pi t plus t naught plus pi. And then we're just going to distribute so that we have cosine of 20 pi t plus 20 pi t naught plus 0.6 cosine 21 pi t plus 21 pi t naught plus pi. In order to satisfy the condition that x of t plus t naught must equal x of t, we know from the previous example that t naught must be some integer multiple of 2 pi. So what we can do is pull out the t naught from both of these. So then we have 20 pi t naught and 21 pi t naught. And we know both of these have to be multiples of 2 pi, but they don't have to be the same multiple of 2 pi, so we're going to denote them differently. So over here, we'll have 2 pi k, and on the other side, we'll have 2 pi m. So then all we need to do is solve for t naught for both equations. On this side, we wind up with k over 10, and on the other side, we wind up with 2m over 21. And the goal is to get these ratios to equal each other. These numbers are a little wonky, so you'll likely have something much simpler to work with on an exam or homework, but it turns out that the only way these ratios equal is if you cancel out the nasty 21 in the denominator. So for that to work, we need our m to equal 21, which cancels the 21 and leaves a fundamental period of 2 seconds. And this means that our k has to be 20, and there we have our t naught. If you want to see this example visually, I encourage you to head over to the video linked in the description that will go over the MATLAB demo. we can repeat this process with something a little closer to what you should expect to see on an exam or quiz. So let's say we have two cosine waves. And let's say this one has a frequency of 10 hertz. So that means we have 20 pi t in here. And let's say the next one has a frequency of 15 hertz. So we have cosine of 30 pi t. And we sum these to get a signal that looks like this. So we want to find if this signal is periodic, and if so, what it's periodic with. Just like last time, we're going to start by plugging in t plus t naught, and I'm going to skip straight to the distributed form this time, just to save some time here. And again, we know that our terms with t naught need to be some integer multiple of 2 pi. So we're going to do the exact same thing, set this equal to 2 pi k, set the other side equal to 2 pi m. We wind up again with k over 10. And on this side, we wind up with m over 15. So we're looking for the greatest common denominator of our denominators. So we have 10 and we have 15. And we know they're both divisible by 5. So we're looking to simplify these ratios to get a denominator of 5. So k is going to be 2. And our m is going to be 3, so that we have a period of 0.2 seconds. So that's how you find the periodicity of a signal that is a sum of sinusoids. I encourage you to continue to the MATLAB demo video, but otherwise, that's all from me. Thank you for watching.